All right, in this video, we are going to find the area of the green part of this figure. We've got a circle nestled inside of a right triangle. So just let's get started on this. And so one of the things you're going to have to know on this one is you have to know that the tangents are equal. So when I see these two lines right here, I know that one of them is 12. That means the other one has to also be 12. And then I can see down here, if this tangent is 8, that means that tangent also has to be 8. So I now know that this hypotenuse is equal to 20. Way down here, we don't know what this length is, but we know it's the same as this length. So these two lengths have to be equal. So let's just call those x for right now. And now we have a beautiful Pythagorean theorem. So I've got, let's see, x plus 8 squared plus x plus 12 squared is equal to 20 squared. So basically that x plus 8 is this leg squared. And then we've got 12 plus x squared is equal to 20 squared. So there's our Pythagorean theorem. Now we just have to do a little bit of math here. And so we're going to end up with x squared plus 16x plus 64 plus x squared plus 24x plus 144 is equal to 400. All right, so now we're just going to do some simplifying here. And so that's going to give us 2x squared plus 40x. Let's see, 1, 2, 3, 4. Yeah, 40x plus, and then what is 100? Oh, 208. There it is. Then plus 208 is equal to 400. And we get rid of that 400 on both sides. And so we end up with 2x squared plus 40x. 400 minus 200 is 200 minus another 8 is 192. So we got negative 192 is equal to 0. All right, so now we have to keep going, because basically what we're doing is we're trying to find the value of x. And then once we get x, that's going to help us figure out the area of the triangle. It's going to help us figure out the area of the circle, and then we can subtract. So we're just going to keep chugging away. I'm going to divide everything by 2. That gives me x squared plus 20x minus 96. Is that right? 96. Yeah, 96. Okay, so then we've got, so now I have to factor this. I could use the quadratic formula, but I always take a second just to see, can we just hammer this out using factoring and prime factoring? And so let's see that. So 96, if I factor out a 2, that gives me 48. If I factor out a 2, that gives me 24. I factor out a 2, that gives me 12. And now I already know 12. 12 is 2 times 2 times 3. And so now what I'm looking for is some sort of combination that is going to give me two factors that will equal 20 if I add them or subtract them or something like that. And so like these guys, that's 8, and these guys are 12. So 8 and 12 is 20, except I know one of them has to be positive and the other has to be negative, because that's how we're getting negative 96. So I'm seeing it now. Yay, I see it now. I got right here. So 2, 2, 2, and 3. So that's going to give me 24. 2 and 2 is 4. So there 4 times 24 is going to give me my 96. And that definitely is going to help me with the 20, getting that 20. So I see that we've got our factors. We've got x and x. I know one of them is going to be a 4. The other is going to be a 24. That's because of this stuff over here. And since I need a positive 20, that means it's got to be a positive 24 and a negative 4. That's going to give me my negative 96, and it's going to give me my positive 20. So what does that mean? That means either x minus 4 has to equal 0, or x plus 24 has to equal 0. And that's because this number times this number equals 0. So that means either this is equal to 0 or this is equal to 0 or both. And so now we automatically know x is either 4 or x is equal to negative 24. And we know x cannot equal negative 24. And how do we know that? Well, we know it can't be negative 24 because if x equaled a negative 24 right here, that would make this entire length a negative. And you can't have a negative length in this problem. So we know it cannot be negative 24. That means x has to be 4. So now we know that x has to equal 4. Boom, there is my 4 and there is my 4. And so now I know that this length right here is 12 and this length right here is 16. And so now I can find the area of the triangle. That's pretty easy. But how are we going to find the area of the circle? So let's see, I'm going to shrink this, get it out of the way because I don't need it anymore. And let's shrink all of this because I don't need any of this anymore. All right. And move this. All right. So now what? Well, if I need to, I know actually here. So I know that this length, these are the radiuses, the radii of that circle. And I know that that is 4 because I got this guy being 4, which means this guy is 4. This is 4, so this is 4. So these two radiuses, the radii, are 4s. So now I know the enough of the information to find the area of the triangle. I know the radius of the circle, so I can find the area of the circle. Now all I have to do is find those two areas and subtract. So let's do it. So let's see. We've got the area of the triangle minus the area of the circle. And that's going to be the answer we're looking for. All right. So the area of the triangle is 1/2 times 12 times 16 minus the area of the circle. And that's going to be pi r squared, which is pi times 4 squared. And let's just kind of hammer out this math. So this and this cancel, so that gives us 6. So 6 times 16 is 96 minus 16 pi. We could factor out, let's see, 2, a 4. Can we factor out a 6? Yeah, we could factor out a 16 if we wanted to. And that gives us 6 minus pi. So there is our answer. 16 times the quantity, 6 minus pi. We could have left it right here as 96 minus 16 pi if we wanted. And that wraps up this beautiful, beautiful little question. We found that the area of that green stuff is 96 minus 16 pi. And if you made it this far, go ahead and hit the subscribe button, hit the like button, and definitely leave me a comment if you know a quicker way to solve this problem.